Hey guys, this is Jason with 4Locked Offroad. Today I'm going to show you how to rebuild electrical actuator on commonly found on 2001 and 2002 4Runners and some first-gen Tacomas as well. Please like and subscribe, share and comment. Add your questions to the comments below. If you want to support me, I have several stickers on my website, 4lockedoffroad.com. Please check them out. He's not a sponsor of this video. I just want to give a shout out to Josh at P&W 4Runner Connection up in Marysville, Washington. I told him that I was searching for a 2002 4Runner transfer case. Before I know it, a couple of weeks later, he messages me and says, "Hey, I found your transfer case." So that's amazing. He went out and found me a transfer case. He knew I was looking for one, and he hooked me up. You're gonna need an extension, makes life a little bit nicer, a 10mm socket, a ratchet, any kind of good grease that's gonna survive any sort of heat environment. It doesn't get too hot in here, keep things lubricated, and something electrical safe. There are some electrical contacts that we need to keep continuity with, so I'm using this. If you know of anything better, please add it to the comments below. Let's review some and define some terms really fast, so we're both on the same page. This whole unit is referred to as the actuator in the factory service manual. You got two pieces to this. You have this black piece, this whole round black piece. That's the electrical side with a motor and some electrical contacts. And then the other half, closest to the propeller shaft flange, you've got this cast iron or cast steel piece. This is, I guess I call this the mechanical side of it. And something goes wrong with this, even if it's caused by the electrical side, the manual says, "Oh, just pull this whole thing out and chuck it and throw a new one in for like $600 or whatever they go for." A lot easier to actually rebuild this and recondition it. This I call the actuator motor, or simply the motor. It's this round piece right here hanging off the actuator housing here. This actually has the magnetic motor and whatnot and the motor screw drive that turns a gear in here. Then we've got the actuator cap or the actuator housing. I don't have a better name for it, and the factory service manual doesn't talk about it because they don't talk about separating these into two halves. This is the actuator housing or cap. Then we've got the actuator gear. You'll see that a little bit later. There's a gear in here that turns, that moves a rod left and right to change the drive position of the transfer case from two-wheel drive to all-wheel drive to four-wheel drive center locked. And then we've got clockwise and counterclockwise. We got to define these. When I refer to turning the gear clockwise and counterclockwise, I'm referring to turning it from this side, from this perspective. If we could, when we pull this cap or housing off and the gear is still hanging in here, when I say turn it clockwise, you're going to turn it like this. When I say turn it counterclockwise, you'll turn it to the left. Makes sense, right? The reason why I have to elaborate on this is because there's going to be some time when I pull this housing off and the gear is going to come with it. Or if it doesn't, I'm going to place the gear inside of this housing when the housing is on the bench like this. So from this perspective, if you turn that gear like this clockwise, in fact, you're actually turning it counterclockwise. So let's go ahead and dive in with removing the transfer case housing. Again, you can see where the plastic nipple is at. It broke. So this vent hose is not connected, but yours is going to have this rubber hose pushed onto a plastic nipple right there. So you're going to pull this off. If it is hard to pull off, I'm just going to say congratulations. You or someone else was probably servicing this. I've got a reel on my Instagram page. Check it out. The reel has talks about this and shows the dry rot issue. You're going to pull your electrical connector off. And then you're going to remove these three 10mm bolts. And then you're going to pull this straight off. I'm not sure if I said it in this recording or a different take. I've already rebuilt this actuator. So this grease is new, and actually there's less grease in here than I normally would have. Your grease, I'll show you because I have a sample of it. If this is the first time you're rebuilding this, your grease is going to be more yellow. So now we've got the actuator gear I was talking about. That's your actuator cap or housing with all the various electrical circuits. Another thing to note is your transfer case oil might slowly drip out of here. It usually won't be a whole lot, so you might want to be prepared and have a cup ready to catch it. Here is the O-ring I was talking about. So we're going to set this aside. I'm going to put it over here with the 3 bolts. If it came out as a single unit, go ahead and just pull this straight up and out. So go ahead and set these 2 pieces aside, and we're going to grab shop towels and go ahead and wipe everything out, all the old grease. And while you're doing this, be mindful of if there's any water in here, if there's any rust or dirt. I unfortunately do not have an actuator housing on hand that has rust. I'll put some pictures in the video from the first time I did this job on the other actuator housing that's on the 4Runner now. If you've had water come in here, one or more of these electrical circuits are gonna be rusted out. So if you're lucky, it's just a surface rust. But as the example is on my housing that's on the 4Runner now, some of the metal was actually rotted away from the rust. So there's a little divot. Thankfully, that divot, once I had cleaned it and sanded it down with 400 grit sandpaper, it wasn't too bad. The actuator gear still had continuity even on that decaying portion. If yours is rusted out really bad, one or more of these, you might be lucky if you solder the connection in and rebuild it, or repair it. Actuator housing is clean enough. So this is that screw drive for the motor. That's right here. The motor's here. Here's the screw drive. This motor gets power and it turns left to right, and that is what in turn turns this gear left and right to make all the magic happen. You don't have to pull this motor off and clean it and re-grease it. If you really want to, you can. I'll just give you a warning that they have little parts that will probably come out when you're pulling this cap off, and you've got to have you got to be very careful to pay attention so you know all the parts that go together and how. I remember, I think it was this one actually has a tiny airsoft BB bearing on this side that this end of the screw rides on. If you lose that, you're going to be in trouble. So I would recommend clean this out the best you can with wire brush and paper towels. And you can apply 12 volts battery positive and negative voltage to pins 1 and 2. And if you do that, the motor will spin left to right. That would allow you to clean back in here too. And then you can squirt some new grease in here. So you got the rear propeller shaft flange right here and the front propeller shaft flange. So this transfer case, I'm going to move this vent hose out of the way. This transfer case is in 2-wheel drive. You can tell because when you spin this, the front does not spin at all. So I just want to demonstrate the gear, the positions, various positions, or how this moves from 2-wheel drive through all the others. So we're going to turn this. I put this in. Okay. So if I turn this to the clockwise, we heard a click, and it doesn't take a lot of force to turn it. Now when I turn this, both flanges move together. If I try to hold back on the front flange, I cannot turn the rear flange. This is because the transfer case is now in 4-wheel drive. In other words, the center locker was activated or engaged. If I turn this clockwise again, you'll see that the front will turn, but I can stop it. So this is all-wheel drive. So when we turn this all the way clockwise is all-wheel drive. All the way counterclockwise is rear-wheel drive. The center position is the center locker. So those are the 3 positions of this transfer case actuator. I'm going to turn this all the way counterclockwise. back to two-wheel drive. You took this out, just like me, and then you put it back in just like me, because you want it to follow along, right? You want to cycle through the positions. When you put this in, and you're trying to turn it clockwise from two-wheel drive into center lock or all-wheel drive mode, and you're trying to turn it and it's not turning. So it did turn and it did engage center lock, but right now if I keep turning it to go into all-wheel drive, it doesn't turn. I can put a lot of force and it does not turn. So why is that? We've got this little extrusion protruding out. It's a good finger high off the back of here. If you're not paying attention to those, when it's not going to allow you to get to center lock, or maybe you will get to center lock but you can't get to all-wheel drive because this part of the gear is hitting this piece, so it's going to be a hard stop. Let me go make something and I'll be back, and we'll start to learn how these electrical circuits actually work. This light board is going to help show you which positions the actuator gear needs to be in order to engage two-wheel drive, all-wheel drive, and four-wheel drive with center locked. What we got going on here is a 12-volt power source. So this buck converter is set to about 2.4 volts to make sure I'm not sending 12 volts to these three LED lights, otherwise they'll burn out. The second buck converter down here, this is set to about 4 volt. This one I will be using to turn the motor, which drives this screw, will rotate the actuator gear. So we'll go over these circuits in a couple of minutes. I just want to show you or demonstrate to you how this all is going to work. Pin 6 is used for four-wheel drive center lock. Pin 5 is used for two-wheel drive. Pin 4 seems to be a common, which I'm assuming is either a common negative or it is a common that's providing 12 volt power from the four-wheel drive ECU. Then pins 3, all-wheel drive. Pins 2 and 1 is to turn the motor. You click your four-wheel drive button. As you know, the four-wheel drive button is all-wheel drive, right? Because these have a center lock mode. So I'll go ahead and turn this motor until only the all-wheel drive light is on. So we are at the opposite end. Okay, so now to verify, I turn the rear flange and you can see the front drive shaft spins with it. If I hold the front drive shaft flange, I can still spin the rear flange. Now you click the center lock button. Now to test it out, yep, I cannot turn these separately or stop the front. They have to turn together. So now we're in center lock mode. Let's say you click into click center lock off. Center lock is off and we're back in all-wheel drive because you never unclicked all-wheel drive. Okay, now let's say you click all-wheel drive off. We'll spin the motor the other way until only two-wheel drive is lit up. There we go. Now we're two-wheel drive mode. Spin this. This doesn't spin at all. So that's more or less how it works. Like I said, I'm not sure if the four-wheel drive ECU is sending positive voltage to pin number 4, or if it's sending positive voltage to pins 3, 5, and 6, and then 4 is a common. Whatever. The way I wired it up is I've got 2.4 volt positive going to pin 4, and I'm treating pins 5, 6, and 3 as negative to power these lights before it goes back to the power source right here. After consulting the factory service manual, I determined that the four-wheel drive ECU terminals 9, 22, and 8 are sending a positive voltage to the transfer case actuator connector pins 5, 6, and 3. Actuator connector pins 4 is a ground, and the four-wheel drive ECU terminals 13 and 26 are sending positive and negative voltage to the transfer case actuator pin 1 and 2 to turn the motor left and right accordingly. As you can see, it's actually not too complicated. I know a lot of people, they don't like the 01s, 02 Tacos and 4Runners because of this electrical actuator. The factory service manual doesn't talk about these specifics on this actuator housing half because they just want you to pull this whole actuator assembly out, toss it, and put a new one in. So none of this is documented, and as you'll see here in a minute, the only thing they've documented on this electrical side is to test the continuity between these pins. And we're going to talk about this briefly because the factory service manual that gets passed around on the internet that I have, it's actually wrong, and we will dissect that right now. Okay, so here's one of the factory service manual pages that talk about testing the actuator by testing for continuity on each of these pins. When I say each, I mean 6, 5, 4, and 3. 1 and 2 they don't talk about because that just turns the motor. Let me just add some coloring here just so it'll match my wiring on the light board. But this electrical connector, that orientation is actually like this. So pin 6 from your point of view is all the way on the bottom. That's this red wire. Pin 1 is all the way over here, close to the motor. So we are in two-wheel drive. They say that there should be continuity on pins 4 and 5 and none of the other pins. That is the case right now. As you can see, we have 1, 2, 3, 4, and 5. So these two pins have continuity, which confirms it is two-wheel drive. Now, let's move this into center lock mode. Center lock is on. You can see my red LED here. Pin 4, because 4 is common, positive. So pin 4 and 6. Well, what do we have for center lock? It wants continuity on pins 3 and 4. So that's not right. So they just made a little typo. So, okay, where are pins? 4, 6 shows up for all-wheel drive in this table, not center lock mode. Center lock mode shows continuity on pins 3 and 4. Well, 3 and 4 are actually all-wheel drive mode. And you can see we have first pin here, second pin is currently not connected to. Third pin is the white wire. You can see the white wire is on my display board is for all-wheel drive, and you also know when this light is on, you know that it is in fact in all-wheel drive mode because I've shown you many times by spinning the flanges. L4 and high four-wheel drive in this table should be flip-flopped. This threw me for a loop. It took me a while to realize that I was working against a typo in this table as I was scratching my head trying to understand why the continuity was not lining up. Let's dive into those confusing looking circuitry paths so we can understand how it works. So pin 1 and pin 2. As we already know, those power the motor, and a good hint is they veer off to the left and they shoot over this way. Pin 3, 4, 5, 6. Pin 3 comes up and it goes around and kind of makes like a half circle. And then there's nothing. Pin 4 comes up and it makes a complete circle. Pin 5 comes up, veers to the right, and makes another half circle. Pin 6 veers to the right, comes all the way around, and almost makes a complete circle, but it stops shy. We can infer by seeing this complete circle right here, pin 4 is some kind of common ground or common positive. And therefore we can also tell that pin 6, 5, and 3 are more specific to something else. How does the voltage flow from pin 4 to 5, 6, and 3 is on the opposite side of this gear. This outside tab runs along the surface of pin number 6 and its circuit right here. At this middle tab, and this runs along pin 5, also runs along pin 3. This inside tab runs along pin 4. So we already know pin 4 on the very inside is, let's just say that it's getting a positive voltage. That positive voltage gets transmitted through this whole tab, all three, right? Because they're a single piece of metal. The inside tab here picks up positive voltage from pin 4, transmits that positive voltage to pin 5, but not 6 because there's a break. So those three tabs are right here. When I position it right over here where there's a break in circuit 6, right here, you're going to see the two-wheel drive light comes on. Two-wheel drive is on, no center, no all-wheel drive. When this gear starts rotating clockwise, it's going to get right about here. So now we're expecting continuity or voltage traveling through pins 4 and 6. Center lock or four-wheel drive light is on. What we can see is down here there's another break, you know. So now we've got pin 4 has the positive voltage, and pin 3 is right here, and pin 6 stops early. So when the actuator gear is in this position, pins 4 and 3 are going to have voltage or continuity. And now we've got all-wheel drive, and two-wheel drive is off, center is off. So let's see this stuff actually working, right? Because that'll be pretty cool to see. So I'm going to go ahead and rotate this motor to turn the gear counterclockwise now, because all-wheel drive is on the far right spectrum, two-wheel drive is on the far left spectrum, and center lock is in the middle. Spinning the motor the opposite direction. Center lock is now on. Spin it some more. I went too far there. So now we're in two-wheel drive mode. All-wheel drive and center are off. If I lift this up, we will see it's right above this position. So now you know this is two-wheel drive, center lock, and all-wheel drive. The process of reassembling this is pretty simple. I like to get grease inside of this. I like to squeeze some out on these electrical pads. You know the transfer case is in two-wheel drive. If you don't, you know how to make sure it is in two-wheel drive. You pull this all out and you throw the gear in, and then you turn it all the way counterclockwise until it has no more positions. You pull this out, you align these electrical tabs. Okay, so here we go. Goes in like, it's not all the way in. I know it might look like it on camera, but pay attention to this. Make sure this fully seats down. But if I look down here, maybe I can get it on camera for you. Might be too dark. Ugh. So the gears, the teeth of this actuator gear is not actually fully meshed with the screw drive gear inside this electrical motor. So that just means I'll pick it up and I'll try again and rotate it a fraction. There we go. That is now in. And I reckon that is the correct position. If it's in correctly, your four-wheel drive lights are gonna not be flashing. The rotation of this gear is off. The lights are probably just gonna keep flashing on you. So then you know you gotta pull it out and readjust it a little bit. So now you take your O-ring and do not put it in the housing like this. Do not do that. I did that last year, the first time I was reassembling this, and basically I got it in there perfectly, right where it needs to be. But during the process of now taking this actuator housing and pushing it on here, it caused the O-ring to get pinched on this cast body. It is not on this O-ring and everything. It must be the O-ring that's on the vehicle now, but there's a little bit of a damage. It's nothing life-changing, so it's not critical, but it could have been. You're just gonna put it on there first. Now it's not going to get pinched. It won't get damaged. Now you're gonna take your actuator housing. You wanna maybe use some 1 or 2 fingers to help hold things so nothing falls out. And then you're gonna put this in and line up the 3 bolt holes. Pretty self-explanatory. And you're gonna just be gentle with it. A little firmness is sometimes required, but most of the time you just stay gentle. So it goes in pretty easy. At some point, as you're pushing it, as you're compressing them together, yeah, there's a little bit of pressure buildup, and most of the time I put this back on, I can hear air being pushed out of this vent hose nipple, which is broken off on this housing. So I feel like this is actually, there we go, it was not straight. So now I can push that on all the way. Now I don't like how that feels. You see, this is a perfect example. Like this is a firm push. And you can see how much space is between the actuator housing and the actuator body, the casted body. So I don't like that. I'm pulling it out. So perhaps it was this needs to get repositioned a little bit different. Let's try that. Easy peasy. Now it's holding itself on. Nothing is pushing it back out. It's easy, it's not difficult to rotate a little bit. So now, pretty simple, just throw your 3 bolts back in. At this point, when you're putting this back on your vehicle, you're gonna plug in your connector. I'm gonna replicate that. Two-wheel drive, light is on, all-wheel drive is off, center lock is off. I know, based on that, the gear and the housing are correctly oriented with each other and installed correctly. I'll turn this. Front flange is not turning. There we go. We'll catch you guys on a future video. I plan on doing an exact video like this, but for the front ADD differential actuator. Give me that like and subscribe, and comment on the video if you found it helpful. If you're running into issues, please comment on the video as well, and I will do my best to help you out. Thank you.